Traditional telephone networks are examples of circuit-switched networks. When Alice wants to connect with Bob in traditional telephone network for a voice conversation, before the conversation can begin, the network establishes a connection between Alice and Bob. This connection is called a circuit. The end-to-end resources along this path are reserved between Alice and Bob. Circuit switching in a link is implemented using frequency division multiplexing, FDM, or time division multiplexing, TDM. In FDM, or frequency division multiplexing, frequency spectrum of a link is divided among the connections established across that link. In TDM, or time division multiplexing, users time share by receiving a dedicated fixed length time slot in a time frame. Let's explore TDM and FDM with an example. Assume we have 4 users indicated by numbers 1 to 4 and color-coded with blue, green, yellow, and pink respectively. Assume we have a circuit-switched link and we want to examine frequency and time allocation in either of FDM and TDM scenarios. If we are using FDM, we have to assign a specific frequency band to each user. This frequency band is dedicated to that user all the time during the reserved time of the connection. You can see this in figure 1, with different colors allocated along the frequency axis. The same frequency will be kept for each user for the whole time that the connection or circuit is reserved. If we are using TDM, a fixed length time slot within a fixed length time frame is allocated to each user. You can see this with fixed length allocation of time to each user along the time axis. Users can send on all of the dedicated spectrum on that specific time slot. The allocated time slot could only be used by that user, and if not used by that user, will remain unused. In figure 2, you can see that we have time frames of 4 slots each, and each user has 1 time slot. If, for example, user 2 does not use their time slot, that time slot will be unused during the connection time.